Our first problem here is a binomial expansion problem. We're going to find the first three terms of the binomial expansion of 2 minus 3x to the power of 5, and we're going to simplify it. So off we go. So first of all, I'm going to write out the expansion using the binomial coefficient. So 5 choose 0. The first thing in the brackets, which is a 2 to the power of 5, and the second thing in the brackets to the power of 0. That's my first term. Then my second term, 5 choose 1, and then we're going to have 2 to the power of 4. And notice how this is going to go down, and that's going to be multiplied by the second thing, and that's going to go up from 0 to 1. Now the third term, 5 choose 2, and we're going to have 2 to the power of 3, and then we're going to have minus 3x squared. Okay, there's my first three terms. Now, if you didn't have a calculator, you'd obviously use the formula for this, but the exam, this is for calculators available. 5 choose 0 is 1, 2 to the power of 5 is 32, and minus 3x to the 0 is 1. Second term, 5 choose 1 is 5, 2 to the power of 4 is 16, and minus 3x to the power of 1 is minus 3x. And the third term, 5 choose 2 is 10, 2 to the power of 3 is 8, and minus 3x squared is 9x squared. Okay, the first term turns into 32, the second term is going to be negative, and 5 times 16 is 80, and 80 times 3 is 240. There we go. And then the third term is going to be positive. 8 times 9 is 72, times it by 10, and you get 720x squared. And there you have it. Now, something a little bit more challenging. We have a cylinder cut from a solid sphere of radius 3 centimeters, and that's talking about the radius of the sphere, and we're told the height of the cylinder is 2h. Okay, so first of all, the first problem is to visualize this. So if you imagine we have a sphere and we chop a cylinder out of it. Now the sphere has got a radius of 3, but not necessarily the cylinder. The cylinder could be a little narrow cylinder like this, or it could be a big, fat, thin cylinder like this, or it could be something in the middle. So if we view it from the side and we flatten it out, then you'll see it's a bit more straightforward. So here's our cylinder. It's going to be chopped out like so. The height of the cylinder is given as 2h, and we know that the distance from the center of the sphere to here will be 3, because that is the radius of the sphere. Now, if we put a little line in here, you can see we have two right-angled triangles, and each of these lengths here is going to be h, and there's a 2h there. And that length there is the radius of the cylinder, which is what we're after, the radius of the cylinder. So for part A, the radius is equal to the square root of 3 squared minus h squared, and that's just Pythagoras used on this right angle triangle here, and that does simplify to the square root of 9 minus h squared, and that's part A. Right, part B, we're asked to find the volume of the cylinder. So the volume of a cylinder is the area at the end, which is pi r squared, times the height. Now, we know the height is 2h, and we know the radius is this. So the volume is equal to pi times the square root of 9 minus h squared squared times the height, which is 2h. And that will simplify to 2h pi. If we square this, it cancels out the square root, so we're left with 9 minus h squared. And as you can see, we've just done part B. We have shown that. Okay. Part C. Find the maximum volume of the cylinder as h varies. Okay, so as h varies, volume is going to vary, and you can see that this is a cubic curve, and it's going to be a negative cubic, which means that it's going to be doing something like this. Now, so it's going to have a minima and a maxima, and we're obviously after the maximum. And you want to find a maximum of a curve, and you need to differentiate it. So first of all, we just need to change the form of it. So v is equal to 2h pi times 9 minus 2h cubed pi. And I'm going to just rewrite that a bit nice and more pleasantly. 2 times 9 is 18. It's 18 pi times h. And then we're going to have minus 2 pi h cubed. So there's our equation of our curve, and now I'm going to differentiate it. dv by dh. And dv by dh is going to give us 18 pi minus 6 pi h squared. Now, for minima and maxima, the gradient is 0. So we move on to 18 pi minus 6 pi h squared equals 0. That, by the way, is my dishwasher. Rearranging over to the side, 6 pi h squared, divide both sides by pi, divide that by 6, and we end up with h squared equaling 3, and that means that h is equal to root 3. Now, just remember, when you square root it, there are two answers, but having a radius of minus root 3 doesn't make a physical lot of sense, really, and either way, the size is root 3. Now, what we're going to do now is we're going to verify that that's a maximum. So we're going to calculate the second derivative, and the 18 pi is going to vanish, and we're going to be left with a minus 12 pi h. And you can see that when h is equal to root 3, d2v by dh squared is less than 0. It's because it's going to be negative, and that means we've got a maxima, which is ideal. So it just remains to actually find the maximum volume of the cylinder. So the volume is equal to 18 pi h, which is root 3, minus 2 pi h, which is root 3 cubed, and that's for the original equation. And now we're just going to simplify this. We've got 18 pi root 3, and then over here we've got root 3 cubed, which is root 3 times root 3 times root 3, which is 3 root 3. I hope you can see. So the 3 gets multiplied by the 2 to get 6, so 6 pi root 3, and that all ends up being 12 times pi times root 3, and it's, I believe, cubic centimetres. If you got there, well done. There's quite a lot there, wasn't there?